Shrivas, and today we have with us a very special guest, also my cousin, Dr. Sindhu Satyavolu, who is a postdoctoral researcher in Spain, Barcelona, specializing in astrophysics. Hi, Akka, thank you so much for joining us here today.
Hi Srinidhi, thanks. It's lovely to be here.
How do you feel today, like in general? Like, it's like you've come to a whole new country, and is it exciting?
Yeah, it's been a busy and exciting week for me. I have been in Berkeley the whole week here, attending a conference related to astrophysics, which I think we'll talk about more as the talk goes on. But yeah, it's been quite a busy week, and I've met a lot of new people, a lot of scientists, so it's quite exciting.
And how are you doing in general also?
Yeah, I'm doing good. I just moved to a new country like 8 months ago, so I've been adjusting, and then yeah, I like my new job that I have right now, and so yeah, I think things are falling into place.
Okay, so can I ask, just for the viewers, like understanding this question, can I ask about what this new job is in Barcelona?
Yes, so I'm working as a postdoctoral researcher at the Institute of High Energy Physics in Barcelona, and I'm in the cosmology working group. So we study the science of how the universe evolves over time, and I'm a theoretical physicist, so I work mostly with simulations, and also I use data from different telescopes, both on the ground as well as in space, to understand how the universe has been evolving and how galaxies form and questions like that.
Nice. So it's like kind of like a distant type of thing, and is it like what exactly made you get into space and interest in astrophysics?
Yeah, that's an interesting question. So ever since I was young, I was always interested in science, not particularly astronomy, but anything related to physics and science. I initially wanted to be an engineer. I wanted to do engineering, and I thought I'd work more on applied physics. So I was fascinated by how everyday objects work based on physics. But during my undergrad, I did a course on special relativity and then general relativity, which is the theory of gravity as proposed by Albert Einstein. And just the concept of how space and time are how gravity can be explained in terms of the space-time fabric, and the concept of relativity itself, like how there's like you have the time dilation, and you might have heard of the brothers paradox, the twin paradox, and so on. Yeah. So these things like fascinated me. I think that was around the time when Interstellar also released. So it was like, oh wow, this is much cool.
Yeah.
And then I also did some courses on quantum physics, so I was totally fascinated by how abstract, or how abstract in general the physics was, and I wanted to learn more about it. So that's how I decided to do a reading project on cosmology, and eventually I decided to do a PhD in astrophysics.
So was your bachelor's also based on that type of field? Like, I know you took a course then, but was it related to the field?
Yes. So my bachelor's was in engineering physics. That's the name of the course. So it's a course where you do both courses in electrical engineering as well as physics.
Okay.
So I had courses on analog circuits, digital systems and processing, while also doing bachelor's physics courses such as statistical mechanics or classical mechanics, apart from quantum mechanics. And special relativity was something that I chose as an elective because it intrigued me.
So like, even when you were younger, you must have had to study a lot, because this seems like a very heavy field with a lot of different variables that are harder to predict, like other than stuff you can find on Earth, because it's outer space.
Right.
So did you also research a lot about that, or like spend a lot of time on that in high school as well?
Well, so I did attend a lot of outreach events, as we call it now. Now that we are astronomers, we call these outreach events that happen in schools where scientists or astronomers talk to kids and then have observation sessions where they point the telescope to the sky and show celestial objects and like a moon, Jupiter, and then Saturn, the rings and the moons of Jupiter. These are the things that we generally used to see. So that was fascinating. That was during school. I probably attended a few of them, but during engineering, during my undergrad, I used to attend a lot of colloquia, like public talks. That's meant for public audience. And that's where I first heard about like concepts like dark matter, dark energy. So there's this thing where the universe itself consists of like matter, the usual matter around us that we see. But most of the universe, apart from matter, is in the form of some mysterious matter called dark matter. And then there's also another mysterious energy that we call dark energy, which we know very little about. And so I was surprised to learn that all that we know about the universe is just 5% of what exists. So
is the dark matter the thing that like warps time and space? Like when you take pictures, like there's some inconsistency. Is that what?
No, I think you might be thinking of gravitational lensing. So what gravitational lensing does is, like, if you have a very massive object, it can even bend light. We know that by gravity, any massive objects get attracted.
Right.
But light, which is like particles, if you consider particles, doesn't have mass, but gravity can also bend light.
Because it pulls it towards it?
Yeah. And so this is what causes distant objects to have imaged in a multiple way, like just like any mirror or lens that you have in front. But dark matter itself, we don't know what exactly it is, but we know that it should exist for several reasons. One of them is that in a lot of galaxies around us, we find that the stars that are at the edge of the galaxies move faster than what we expect them to move. So if you have, because most of the matter is concentrated at the center, you would think that as you move farther and farther from the galaxy, the stars on the outskirts should probably not be moving at a very fast rate and they should be slower. But we find that they're instead moving at a very fast rate. And then, but we don't see any matter that could actually cause it to move at such a rate. And then that's when theorists like hypothesize that there is a dark matter which only interacts gravitationally. Like there are 4 fundamental forces: gravity, strong, weak, and electromagnetic force. In our daily lives, we only encounter gravity and electromagnetic force. But this dark matter can only interact gravitationally with whatever matter is there around. And because it's called dark matter because it doesn't interact with light, so we don't know.
So we can't really see it.
We can't trace it there because most of astrophysics is through seeing what the object looks like. Although we now also have gravitational wave astronomy, where it's a different field, but astronomy has been majorly dependent on observing the light coming from different objects in the sky. But this dark matter doesn't interact with light, so we never know what it looks like or what it should behave like. But we think that it should exist because it interacts gravitationally, definitely.
So is that what you are mainly focusing now as a researcher?
It is part of what I focus on as a researcher right now. So there's a standard model of cosmology which describes like, okay, there's like 76% dark energy, 20% dark matter, 5% matter, and so on. And so that's the best model for the universe that we have right now, that can explain a lot of the observations that we have. And one component of this model is that it postulates that the universe is expanding since the Big Bang. So
Oh,
we had the Big Bang, and then after the Big Bang, the whole universe has been expanding, and because it's expanding, it's also cooling down, and so on. But the thing that I'm focusing right now is how we measure this expansion rate. So the expansion rate of this universe is actually increasing at an accelerating rate.
So it's
That's
becoming faster,
It's faster. It's
Okay.
it's expanding, and the rate itself is also
increasing.
increasing. So we are expanding at an accelerated rate. And this was discovered in 1998, for which they won the Nobel Prize in 2011, I think, if I'm not wrong. And so, yeah, measuring this expansion rate precisely will tell us about what could be causing this accelerated expansion. Because if you have these massive objects like galaxies and clusters of galaxies around, there's always gravity attracting these.
Right.
But unless there is some opposing energy, like the dark energy, which is like counteracting gravity, so that you still have accelerated expansion.
So, is it like dark energy? It also works in the same way as gravity, but to only the objects that are there. It's kind of
Yeah, it's a difficult question because we don't know what it exactly should be, but we just have it. There are several models to explain what dark energy could be. Some think of it as a negative pressure fluid with negative pressure. It's not very how do I put it? It's not very intuitive to discuss, but yeah, the short answer will be that we don't know exactly what it should be, and that's why it's exciting.
So, it's like still something that it's like the unknown, the mystery of solving.
Right.
Is that part of the reason you're like still doing it today? Like because it's like exciting to know something that we don't know yet, and it's like so interesting because
Exactly.
that's why all of my friends who are interested in space are like, oh, the stars, like there's so many things to learn about them.
Right.
And that's what brought you into this field.
Exactly. I think curiosity is really important, and that's what drives us as humans. And so, I'm curious about what there is to be known here.
And is this also like the topic of your research? Is that what you're also presenting now here in California as well?
Yes.
Okay, so like, can you explain a little bit about how they work though, like the lectures or the speeches?
Yes. So I was at a conference, or it was rather called a collaboration meeting, and I'm a part of this collaboration called DESI, DESI, which stands for Dark Energy Spectroscopic Instrument. And DESI is a telescope that's at Kitt Peak in Arizona. And yeah, it's a large sky survey in the sense that it will look at the entire sky for long durations, and so there are some telescopes that are focused on only certain patches of sky, and then they go deep. These are called deep surveys, which will look, the deeper you look, the longer back in time you're looking at.
Oh, okay.
Right. And so, but this is a wide survey, so it will cover a large number of galaxies. So I think DESI has like 40 million galaxies. It has observed about 40 million galaxies and quasars, which are like supermassive black holes that are usually at the centers of massive galaxies. And and this was the collaboration meeting for DESI researchers working within DESI, like from everyone, including the ones that built the instrument, the ones that are operating it, the ones that are doing the observations and reducing the data for us, and then the theorists, of course, who are analyzing this data and making predictions for what the model of the universe should be. And typically academic conferences work, it works like any academic conferences, so you have 5 days where in each day there are different dedicated sessions for each subtopic
in the whole thing.
in the whole field, and then usually there are talks and discussions. We have some talks by early career researchers telling us about their work, and followed by questions, and then at the end there's also a discussion about, okay, what have we done so far, what could be done next, and how do we go about the current projects, and also project planning. And yeah, that's how these conferences work.
Is it a lot of pressure to like have to talk in front of so many different people?
Sorry, I didn't hear you well.
No, I'm just saying, like, is it difficult to talk in front of all these people because they're all experts in their own fields, and is it scary?
Right, that's a very relevant question. When you start, it might be a bit scary, because if you're a first year PhD student, or if you're a master's student, it could be scary because you know that everyone else is an expert in the room. But with experience, I think with experience and exposure, as you give more and more talks, you will feel more and more comfortable, because at the end you realize when you're giving the talk about your own work, you are the expert on it. Everyone else is an outsider to the project, so they might not, even though they're experts, they're not expert on what you have done. So you know, most of the times it's you who knows much better. So yeah, I think exposure helps for that.
Okay.
You give more and more talks, you give more and more podcasts, and you'll feel more comfortable talking about it. So
yeah, because it's still kind of a bit hard for me to like, you know, talk to people like I'm not used to yet. So like sometimes I feel a bit awkward. So
no, you're doing great.
Okay.
Right now.
Okay, thank you. In the end of like general podcast, I do this like introspection portion where I ask like simple questions that like kind of delve into your thoughts on certain topics. Like, for example, I'm gonna ask, what is your meaning of wealth?
Okay.
This is a pretty deep question.
It's a very deep question. Well, I mean, if we go by health as well, I think health would be would rank high on my priority. Wealth, and then love. You know, I'm trying to say anything except money, but of course money is important, but I don't know how to answer that question. But
Okay, would you say like as a researcher, would you say like curiosity and then like knowledge is something that you would rate highly on your list?
sure, I do. But that's not that everything is about. I do rank it high up. I think it's important to be curious and ask the difficult questions and think about it, but it's not always practical. Like, it might not seem on the outside, but science has this privilege. Like, a lot of people who do science are already privileged enough to follow the academic career path, because it's not as lucrative as doing as we academics call it, an industry job, which is like
More like
business or software, like working for companies, and so it's not as lucrative. So yeah, being the academic researcher is difficult. So yeah, there's both practical aspects to it. So I think it depends from person to person.
Is it because there's not as much we know about the topic, so it's not like a set path, and it's more about going into things that we don't know that well?
No, so that could be the part that makes the job difficult, but then it's because of it's because of how the institutions and how governments work, right? You need funding to do science,
Right.
and then each country has a portion of its budget for science, and that differs from country to country, and each country may not want to focus on the same science goals. Some countries might be interested in building quantum computers. Some might be more interested in building rockets and having more, more, and some countries might do more particle physics. So it's depending on their priorities, they put more money into different scientific fields, and so there might not be as much funding as you would need to do a project or run a project.
Mm-hmm. Okay, and one more question. So we've gone into wealth, and so I was also wondering, how would you define success? This is also a pretty difficult question. I probably should have given you a heads up.
Yeah, I'm trying. Let me think. For success, it doesn't have to be what everyone thinks success should be.
Mm-hmm.
Even if I say something is success right now, that would just be for me. So, and also it's a question that keeps changing with age. When you're young, you think success is like, okay, cracking this exam, doing this job, you know. And then when you're a little older, then you realize, okay, success may be, you know, having someone to share your life with, and then have some support with it, and then as you grow even older, then you have, okay, success is watching your kids do well, and then it keeps changing as you age. It can be anything that you want. If you have anything that you want, and if you have it, then it's success.
This question, it's kind of difficult for me because I'm still trying to figure out what I want to do, what my goals are. So like I like to ask this one particularly.
It's actually very natural to feel that way, if you ask me. I don't think anyone knows for sure what they want to do, especially when you're as young as you are. And I've seen it with me. Like I said, I had a degree in engineering before I did PhD in physics.
Mm-hmm.
I've seen it with a lot of my friends who also did engineering but took different career paths. One of my friends is working in administrative services in India.
Mm-hmm.
So I don't think you need to know exactly what you want to do. At this point, it's important to try different things and then decide for yourself, okay, this is cool, I might want to do this. But if you don't find it cool, you try something else and then decide that way. So when you're, just participate in a lot of clubs and try different things, and then find it more to.
I think that should be all for today. Thank you so much. Just going back to your childhood, can I ask if you could elaborate? Oh, it ain't recording, got it. Okay, okay. So I also wanted to delve back into your childhood education a little, like around after 10th. Can I ask, like after 10th, how was it? Because it must have been a bit difficult to transition from studying under your parents' guidance to going on to college, etc.
Yeah, thanks for asking. So immediately after my 10th, I decided to move out of my home to go to a hostel to continue my education for 11th and 12th.
Mm-hmm.
And that was my choice. I always liked to travel and live in different cities, so I thought I should move out and continue my education at a different city. And so I moved to Hyderabad from Vizag, which is my home.
Mm-hmm.
And then I did my 11th and 12th in Hyderabad, and then I got into Indian Institute of Technology, or IIT Madras, which is in Chennai,
Mm-hmm.
where I did my bachelor's in engineering physics for 4 years.
Mm-hmm.
And that was the second transition that I had. This was the first time I moved out of my state within India.
Mm-hmm.
And but IIT, there were people from all over the country, so it was a very diverse, uh, diverse group to be in.
Mm-hmm.
And because in India itself is so diverse, after that I've never had any problems while moving to different cities or different countries even.
Because you had to adjust to all those different types of people.
Right, exactly. So because India is so diverse, you already might have interacted with a lot of people from different backgrounds.
Mm-hmm.
When you move from one city in India to another city in a different state within India. So, and then after my undergrad, I did my PhD in Mumbai
Mm-hmm.
for 6 years, and yes, after my PhD, I was looking for postdoctoral positions, and because I wanted to pick a different research for my first postdoctoral position, I thought I'll join the group in Spain, in Barcelona.
Mm. So in Mumbai, what was your what was the topic or the field that you chose to study in?
Yes, my PhD thesis was on what are called quasar proximity zones. It might be a bit of a jargon, too technical to discuss in detail,
Mm-hmm.
but the idea was that again, quasars are these supermassive black holes at the center of galaxies,
Mm-hmm.
and we were looking at the light from these objects that are coming from nearly 13 billion years ago, because the age of the universe is close to 14 billion years,
Mm-hmm.
and we see these objects at nearly 13 billion years ago. And so I was looking at the light from these objects to understand how the universe in between that quasar and us was like, because the quasar light, while traveling from the quasar to us, it interacts with all the intervening gas that's there. There's this intergalactic medium between galaxies, which the quasar light interacts with, and once you observe that light, you can make models to compare to what you would have expected the light should look like. And then you can tell the age of the quasars and what the temperature of this gas in the intergalactic medium should be. And one of the cool things that we were able to predict from comparing our theory to models was that we predicted that there should be more dust around these supermassive black holes at earlier times. And soon after we did that, a couple of months after we did that, the James Webb Space Telescope, which has been launched, in 23 December, detected, not 23, 22 December, started detecting these objects called little red dots, which actually had, it's just a name for it, but these were also, we think these are also these quasars that are enshrouded in dust. So it was pretty cool to see the telescope actually discover what we thought, what we predicted. So that was a cool result, one of the cool results of my thesis. Yeah.
So about all of this, all of like the physics and the quasars, how can I ask how your family felt about you doing something so complicated and like high level?
Yeah, thanks for asking. I think my family has been very supportive with my decision to do a PhD, and then I feel really lucky that they enjoy the work that I do as much I enjoy it. They're always curious. My dad keeps sending me news articles of new James Webb, JWST discoveries and discoveries from other telescopes, and they're always curious about what I'm doing, and they are equally fascinated by the research that I do. So yes, my family has been quite supportive, and I feel really lucky because I haven't even had to think of, what will my parents agree to it, or will my parents allow me to study this? I've never had to even think about it, so they've given me complete freedom to do what I'd like to do, and that's something I'm really grateful for.
Do they also like study in similar fields? Like you have a younger brother. Does he also study in similar fields, or?
So my father was an electrical engineer, and this is part of the reason why I wanted to study engineering. I wanted to be like my dad, do engineering, and then work on the same things with him. But then I found physics more interesting. Also, I felt that I was better at physics than electrical engineering, and I couldn't really work with hands, work with lab
Like the small
lab
tiny
equipment.
things.
Yeah, I was not that good at it, but yeah, that has been an inspiration for me too. A lot of people in my family are actually teachers. Like my aunt is, my father's sister, elder sister, teaches science to high schoolers, and then my father's first cousins also are teachers and they work in schools. One of them also runs a school. So there have been a lot of people in teaching around my family that I've grown up with. So that also played a role in influencing me to take an academic path. And my brother
Like in
is
research.
currently also pursuing engineering, and yeah, he's more into automotive engineering.
This has been a very good session.